Thank you for joining us today for our very presentation of the day. We will be discussing multi-level cache, L2 cache, address spaces, split cache versus unified cache organizations, which are all within cache memory as a topic in the whole. We'll be talking about multi-level cache and its importance. That will be what I'll be talking about very much here. Definition of multi-level cache. Multi-level cache is a memory system hierarchy in computers to minimize latency. It uses locality principles. Well, we can also define multi-level cache as a caching system that consists of multiple levels of cache memory. Within the levels of multiple levels of cache memory, you have the L1, L2, and then very recently I found out we have the L3. But it's mostly found within high performance machines. Let's go to the relevance of multi-level cache, which is the importance of multi-level cache. Multi-level cache helps boost the performance of a memory. It boosts the performance of a memory in the sense that it stores frequently used information to the processor, keeping it often very close to the processor, speeding up memory access. Multi-level cache optimizes memory usage and minimizes latency. It minimizes latency in the sense that it reduces the access time and then improve your performance for you. Multi-level cache is crucial for efficient computing. It's very crucial for efficient computing, so much that it keeps the data very close and very close to your frequently used information, so that you'll be able to get access to your recent information. And then I think this is all I have for the day. My other colleagues will also help us understand the various multi-level types we have, which is L1, L2, and then probably he will be more precise on the L2 since that's what we are supposed to present. Thank you.
Okay, so in this section of the presentation, we'll talk about address spaces. And in the address spaces, we'll take the introduction, that is the basic definition, look at the types of address spaces, and we'll look at the advantages of address spaces. Alright, so we move on. An address space or address spaces is a way to organize and manage memories in the computer system. They give a logical view of memory, allowing programs to access and utilize memory resources. So the address space helps to utilize the memory in your computer system. In that, when you have an application running on your computer or a program that is running on your computer, it has codes and data which is being saved somewhere in the memory of the computer system. Okay, so the place is being saved is also given an address, so that's why we call it an address space. Okay, so we'll look at the types of address spaces. We have the flat, segmented, paged, and hierarchical. Alright, so we'll take them one after the other. The first one is flat address space. In a flat address space, the entire memory is represented as a single contiguous range of addresses. So when we say a contiguous range or a contiguous memory of something, it is just there's a consecutive blocks of memories allocated to user processes. Okay, so let's move on to the next point, that is the segmented address spaces. When we say something is segmented, it's simply means it's being divided into what parts or segments. So when you read here, it's in a segmented address space, the memory is divided into segments where each segment represents a logical unit of program. It's very simple and straightforward. Now let's look at the paged address space. In a paged address space, the memory is divided into fixed size. Each page is a block of contiguous memories. Alright, so the memory in this aspect is being divided and given a fixed size. Alright, the spaces are being given fixed size, to contain the codes and the data and what have you. So hierarchical address spaces. In a hierarchical address space, the address space is organized in a hierarchy structure. This allows for a more efficient and scalable memory management, especially in a large scale system. Let's look at the advantages of address spaces. Now, we have the memory isolation. Each process has its own unique address space, ensuring that it cannot be accessed or modify the memory of other processes. So this is trying to tell us that if you have an application, maybe two applications running on a computer, the codes and data of each applications are being given different spaces, so they don't have any access to each other. This will protect and enhance the security of your computer system. All right, so the next one is efficient memory management. Address the efficient memory management. It helps to manage your computer system, that is the memory in your computer system, very well. Okay, it's well explanatory right here. So the last one, we have the virtual memory. Address spaces enable the implications of virtual memory system. This allows the program to manage the memory or the disk space in your computer system. You understand? So it means that the code and the data of applications that are running on the computer is not being saved on the main memory, but rather being saved somewhere else, which does not affect the storage or the memory of the main of the computer system. Yeah. So I think that is it for the address spaces. Thank you.
Today, I'll be talking about L2 caches. And my outline for L2 caches is the definition, how we can improve system speed with L2 cache, and merits and demerits of L2 cache. Starting with the definition, we say L2 cache is a secondary part of the CPU's memory used to speed up data access. We're talking about speeding up data access. L2 cache, which is a secondary part of the CPU's memory, helps us to retrieve data more faster. We can also define L2 cache as a secondary memory tier that stores data for quick access, improving overall data speed. We now talk about how L2 cache improves system speed. First of all, L2 cache acts as a bridge between fast, limited L1 cache and slower, larger main memory. 2. L2 stores data that is no longer in L1 cache but might be needed soon, reducing the need for the CPU to reach out to the slower main memory. And L2 cache speeds up data access and overall system performance. It's all about minimizing latency and maximizing efficiency. We now move on to the merits and demerits of L2 cache. Starting with its merits, we say L2 cache is faster than main memory and secondary memory. L2 cache, which is the secondary part of the CPU's main memory, is faster than any secondary memory. For example, a hard disk, an SSD, or a flash disk drive. We now say L2 cache can be split into instruction cache or data cache. And the demerit of L2 cache is it's more expensive than the secondary memory and it requires more power to operate. Thank you.
Okay, good evening, my dear students. My fellow students, sorry. I'll be taking you on this part on the presentation, and my part of the presentation is the split cache versus the unified cache. Okay, split cache and unified cache are two different caches organization schemes used in computer system. Split cache. In split cache organizations, the cache is divided into two separate instructions and data caches. Each cache stores a specific type of data, one for instructions and one for data. Advantages of cache. 1. Improves parallelism. Separate cache allows CPU to fetch instructions and data simultaneously, enhancing overall performance. 2. Fine-tune cache size. You can allocate cache space based on the instructions need. For example, you have a large cache for data-intensive applications. We move to the disadvantages of split cache. That's 1. Complexity. Implementing separate cache adds to the memory hierarchy and requires careful management of cache coherence between the two caches. 2. Potential for wasted space. Unutilized while the order is congested, leading to inefficient cache usage. Now we move to the unified cache. It's a single cache for instructions and data. In unified cache organization, there is a single cache that stores both instructions and data. Advantages of unified cache. Simplified design. Unified cache are easier to design and manage because there is no need to handle complexities of separate instructions and data. As you can remember in the past definitions, I'll take you back to another time to save time after we move fast. Pardon. 2. Improve cache utilization. A unified cache can adapt to the dynamic needs of the running application, potentially reducing the wasted space. Disadvantages of unified cache. Potential for contention. Potential for contention when both instructions and data access the same cache. There can be contention for cache resources, potentially leading to slower access time. 2. Limited control. You have less control over the allocation of cache between space instruction and data. Now to the summary. In summary, the choice between split and unified cache organization depends on the specific requirement of the computer system and the workload it will handle. Split cache offer more fine-grained control but are more complex. That's like it's somehow a bit hard when like you're trying to work with it, something like that. While unified cache simplify design but may face contention issues. Even though the unified cache is easy to work with, you might still face some 1 or 2 challenges along the line, but that's what you are given to be the simple way, so we move with that. Okay, so the decision should be made considering the trade-offs in particular context. Thank you for your time.